Hello again everyone, this is Mr. Hoy. In this video I'm going to be solving an equation that involves a radical. Here we have a variable under the radical, the 3x plus 31. We're solving the square root equation first by trying to isolate the square root. In this example, the square root is already isolated on the left side. So what we want to do here is we want to square both sides. We want to square this side to get rid of the radical, and because we did it on the left, we do the same thing on the right. The left side, as I mentioned before, would be 3x plus 31. Taking the square root is the opposite of squaring something. So we took the square root originally, we square it now. X plus 9 needs to be squared as well, so x plus 9 times x plus 9. That's going to be x squared plus 9x plus another 9x plus 81. We combine the middle terms to get x squared plus 18x plus 81. Carry that over here, x squared plus 18x plus 81. All right, now we want to move terms around to isolate the 0 on the left side. We've already got an x squared term here, so it's going to be easier to move these terms this direction. Start off by subtracting 3x from both sides. Then you'll get 31 equals x squared plus 15x plus 81. Then you can subtract 31 from both sides, and you'll get 0 equals x squared plus 15x plus 50. You may recall from a previous chapter, we were doing the zero product property. We would get the 0 by itself and factor the right side. We're going to do the same thing here. We're going to leave this 0 over here. We're going to look to factor this side here. Because we have an a value of 1, we don't need to go through the full AC method, and instead can just look at the c value and look for factors that add to the middle or b value. We've got a positive 50 here, so we're looking for two factors of positive 50 that add to 15. Those two factors, in our case, are going to be positive 10 and positive 5. So now we've got 0 equals x plus 10 times x plus 5. We then want to set each of those equal to 0. That's x plus 10 equals 0, and x plus 5 equals 0, because the only way for this to be true is if one of them is 0, because 0 times a number will be 0. Here we subtract 10 from both sides, we get x equals negative 10. Here we subtract 5 from both sides, we get x equals negative 5. You may be tempted in this question right away to assume that these are the both correct answers. When we're doing some of these problems, we may be in a situation where one or both of the solutions is extraneous. Essentially means an extra solution that we created that's not really a solution to the original problem. So if we go back to the original question and we try to plug in negative 10 and negative 5, it's possible that one or both of them won't actually work after it's substituted. I'm going to go over here and I'm going to substitute some values in to see if they work out. We'll start with the x equals negative 10. We plug that back in everywhere where you see an x. So that's 3 times negative 10 plus 31 underneath the radical equals negative 10 plus 9. And all I'm doing is I'm taking this answer, plugging it back in. This is then negative 30 plus 31 equals negative 1. This is the square root of 1 equals negative 1. And because the square root of 1 is not actually negative 1, we would say that negative 10 does not work and that negative 10 is extraneous. All right, from that point, we want to check our negative 5 to see if negative 5 works. You again plug the negative 5 in everywhere you see an x. 3 times negative 5 plus 31 under the radical equals negative 5 plus 9. The right side becomes 4. Under the radical is going to become negative 15 plus 31. This is positive 16. Under the radical equals 4. The square root of 16 is 4 in this case, so we can give that one the check mark, meaning that negative 5 is our actual answer to this question, and negative 10 is an extraneous root, or essentially an answer that, while mathematically being accurate over here, is not accurate when substituted back into the equation because of the root we created by squaring it. So, to recap, starting the question off, isolate the radical. Square both sides, in order to get rid of the radical. At that point, you'll do the FOIL method as we did here in blue to get what we have there. Isolate the 0 by subtracting or adding terms as appropriate. Now we've got a 0 by itself. Then from here, factor the right side. Here again, we've got a value of 1, makes the factoring a little bit easier. From there, you want to break off this x plus 10 and this x plus 5 and solve each of those individually. When you set them equal to 0, you'll get 2 answers. At that point, just pump the brakes a little bit. You're not quite done. You need to just make sure both of those actually work. This is where we plug in the negative 10 here and the negative 5 here. And we see that the negative 5 does work while the negative 10 does not actually work. So when you walk through those questions, it's going to be a little time consuming, but make sure you're doing each element correctly and you know what step comes next, because you've got to isolate 0 before you can factor, and after you factor, you'll have your answers. Don't jump the steps, don't start factoring up here before you get that 0 by itself.